In this video, we're going to take a look at using the Donic drag knife with the Vectric gadgets. We're going to do this in a couple parts. First, we're going to just quickly take a look at the gadget and create toolpaths based on the drawing that we have. We're going to then take a look at the actual video of it actually cutting. Then we'll come back in and take a little closer look at how we created what we have here. So the first thing we're going to do is select the objects that we want to create the toolpath for. Go to Gadgets, then to Drag Knife Toolpath. The one setting I do want to point out is this swivel depth. That is kind of the key to getting the sharper corners or getting the swivel and the knife to operate properly. We'll see this in the video. Coming down, selecting OK. Now creates our toolpaths. You can see that by having our toolpath in the list. At this point, you would click Save Toolpaths, save the toolpaths out using your appropriate post-processor for your machine. Once they are saved, you could take this cutting file to your machine and run it. Now we're going to go take a look at this cutting now. Okay, now that we've seen it cut, we're going to take a closer look at what we did to create the toolpath and maybe have a better understanding of what we're seeing here in the preview. The first thing, we're going to take a look at the Gadgets menu and go to the Drag Knife Toolpaths. Just going to talk a little bit about what each one of these settings is for. So the first is the cutting depth. This is how deep we're going to be cutting into the material. As we saw in that video, getting an accurate Z0 and an accurate material thickness is critical in getting a clean cut. For one, the cutting depth needs to be able to go all the way through into the spoil board just a little bit. And then this swivel depth. This is the height at which the blade pulls up to where it creates this arc move to position the knife in the orientation for its next cut. So before I change anything here, I'm just going to close the gadget here and take a look at what that move looks like. So in the video, the slow motion section right around 2 minutes into the overall video, is it had come down to a height, then did this swivel arc move. Now the arc is a smaller arc that you can't tell that it moved in this arc motion, more or less saw the knife swiveling and rotating around. The reason that it was able to rotate around is because the tip of that knife was into the material by what we have set in our setting for the swivel depth. The smaller you make this number here, the less likely that you will have any kind of marring or surface tearing as it swivels around. Again, we need to have the tip of that knife just barely touching the surface of the material as it rotates around. Another setting that we need to look at is the blade offset. If you notice on our toolpath, we can see that it somewhat overshoots the path of our selected vector. This distance from the edge of this vector line to where the blade is pulling up, which is again out here, we could see that it is overshooting what appears to be overshooting the selected vector. Now that is the distance of our blade offset. So at the surface of the material, this is the distance that the blade is. But at the surface of the spoil board, or cutting all the way through, the tip of the knife is sitting right here at the corner of our selected vector. And to be able to better explain that, we're going to take a look at the knife itself here. So this line is the center line of the knife. And just zooming in here, the blade offset is the distance from the center line to the back edge of, or the tip of that blade. So at the surface, this is where it's coming through. This surface here is this overshoot out here, but again, the tip of the blade is sitting at the rotation or the connecting points of the two vectors. And the reason that is important is to be able to allow the knife to be able to swivel around when we move up to our swivel height for the blade to swivel. So with that taken a look at, we are going to take and kind of follow through what is happening here in this tool path that has been calculated. The starting path, it comes down to our 0.01 into the material. Then the machine is going to make this arc move to position or rotate the knife in the direction of the next cut. And at every angle that is greater than our threshold angle set in our gadgets, the tolerance angle, the blade or the machine is going to lift in the z-axis to the specified swivel depth. Now the swivel depth is kind of a hard one to explain without actually seeing it. So that depth is not how much it's pulling up out of the material, it is how much the tip of that blade is still into the material. So again, we want it to be just a very small number, but we do have to have it to be a number that which the blade is going to be touching the surface of that material. So it is going to flow through, overshoots by the blade offset. As it raises up to that 0.010 into the material, the tip of the blade, you will notice, is at the corner of the two vectors, or the intersecting vector here. As it does a swivel move, it is going to position itself and rotate the knife in its set direction. Now there is a little bit of back and forth play with this. As it rotates around, it may not perfectly rotate, as we do have a little bit of drag on that knife, and it may not position itself perfectly parallel to the cut. And this is why you might get a little bit of a offshoot or outside cut as it continues on when it moves back down into depth. To be able to create and correct this, this is what we've done on the bottom side. Added these loops onto the outside of our vectors to be able to create a more continuous flow of cutting. In what we have on the bottom set of vectors is we do not have the positioning moves other than, or that swivel moves, other than at the beginning and the ending of the cut. So at the beginning of the cut, it does not know what orientation the blade is, so it does need to present this swivel move into the material before we move on. So it will create its swivel move to orient itself to the direction or the path of the cut, which is off to the right. It is going to sweep around the corner and up and sweep around the corner. To create these outer sweeps or these outer radius, we use the fillet tool and setting the plasma drag knife fillet. That is creating that loop on the outside. So this is a good technique to use if you're cutting on the outside or any outer type cuts. You're going to get a much smoother flow and sharper corners, creating a fillet on the outside this way. So to create this fillet, you would just specify the tool radius and simply click on the corner or the adjacent angle or the angle of which you want to have this loop created. The size of this loop depends on the tool radius, and it also depends on how big or small you make this tool radius is dependent on the thickness of your material. If you're cutting very thin material, you may be able to go with a tool radius that is much smaller. If you're cutting thicker material, you may need to create a tool radius that's a little bit thicker. So the reason that we have to pay attention to this is, imagine if we are cutting this full depth from this location, from the bottom tip of this knife to the top of the total depth of here. So now what we have is a total width that we are cutting from the leading edge of the knife on top versus the back edge. As that knife rotates through the material, is there a big enough radius to allow this knife to not bind as it is swooping or cutting around the specified radius? So the deeper you cut into the material or the thicker your material is, the larger this radius would have to be. So once we have specified all the locations where we want to have our vectors to create the toolpath for this, you would simply select all the vectors that you would like to have the drag knife be applied to, go to the Gadgets menu, the drag knife toolpath, and again, just going through here, we have the cut depth of 0.07. This is how deep we're going into the material. Typically, it would be all the way through. The swivel depth is at how deep into the material we'll be moving to create that swivel orientation of the knife. That swivel depth is not how deep into the spoil board it is how deep it is into the surface of the material from the top of the material down. That doesn't have anything to do with where you have zeroed the Z. It just has to do with how deep into the material it is going to go. Specify how many passes you would like the knife to make. The blade offset. This is the offset of from the center of rotation to the back tip of the knife, as I pointed out in that drawing. That is the amount that it overshoots from the top surface to get the tip of that blade to be at the corner of our rotation or at our swivel action. The tolerance angle is the difference in angle between two lines that it will require the knife or the blade to lift up and rotate. Once that is done, you would have to select a tool. Now, it could be any tool. It just needs somewhat of a data in there to be able to get the feed and speeds. Once that is selected, you would select and then scroll down and click Calculate. That would then put our toolpath in the toolpath list. Notice I already have the one here from creating the video. We could hide that or make that invisible by unchecking that, and we could see the difference between the two. We added the fillet on the outside sweep versus this toolpath, which is creating that lift up and swivel. So the bottom section, or this bottom toolpath here, is what's going to give us the cleaner outside corners when creating a file for drag knives. I hope this helps explain some of the issues you might be having, or some issues that you may have seen. And that is all I have for this video.